Today I'll be presenting on quantum batteries, the physics of future energy storage. Energy storage is at the core of our sustainable future, and conventional batteries are simply not enough. In this talk, we'll explore how quantum mechanics could transform the way we store energy and use the energy. On average, each person consumes around 80 uh, gigajoule of energy annually, the equivalent of running a washing machine non-stop for a year. Unfortunately, 86% still comes from fossil fuels, driving climate change as renewable energy source resource grows. We need breakthrough storage solutions, one that can handle intermittent solar and wind supply while also powering things like electric vehicles. Traditionally, batteries are based on 200-year-old electrochemical principles. They suffer from slow charging times, finite lifespans, and environmental concerns from mining and disposal. Even though with improvements, current batteries cannot meet the energy density, speed, and sustainability demands of the future. That's where the quantum batteries come in. So, a quantum battery is a radical new approach. It is still new, and we have to still make a lot of exploration in this field. Quantum batteries harness two powerful concepts of quantum physics, that is, superposition and entanglement. Quantum mechanics is still a topic that is not explored much by our scientists, and they are still working on a lot of technologies that to come up. Superposition allows particles to exist in multiple stages at different at once, enabling new ways to store energy. And entanglement in quantum batteries is basically it links the particles, allowing faster and collective charging. This opens a door to instant charging. It can reduce the charging times significantly, and it can also increase the charging densities. It leads to higher charging densities and a longer lifespans than anything we have seen ever before. So this can really improve the energy demands. This can meet the energy demands within a short span of time, and we can improve it further. So how quantum physics powers energy storage. So quantum batteries don't store energy chemically. Instead, they store it in a quantum states of atoms or photons. So, unlike our traditional batteries, they don't store it in a chemical energy where they charge and discharge by the accumulation of electrons and loss of electrons. Instead, they are keeping it in and storing it in a quantum state of atoms or photons. They also use super absorption effect, where entangled particles absorb energy collectively, making larger batteries charge faster, not slower. So basically, uh, the photons and atoms have a lot of super absorption effect. So if a battery is large, they have a lot of photons and atoms in it, which can absorb energy collectively and make the larger batteries charge fast instead of being slow. In fact, a lot of researchers have already demonstrated this using organic dye molecules, showing this isn't just a theory but real progress. So a lot of Australian researchers proved this by charging the large battery and showing that the super absorption principles does exist, and it's not just theoretical. Breakthrough with time crystals and quantum coherence. Time crystals are exotic quantum states that oscillate without losing energy, helping batteries retain energy for longer. So not only the quantum batteries can charge themselves very fast because of super absorption property, they can also retain the charge for a longer period of time than our traditional batteries. In the recent research by Federico Carallo, it shows that the coupled time crystals could significantly boost the efficiency. So we can further improve the efficiency of the quantum battery by using coupled time crystals. The challenge, however, is that quantum coherence, keeping delicate quantum states stable against environmental disturbance. Overcoming decoherence is the biggest hurdle in making quantum batteries practical. So it's still a theoretical concept that we can use coupled time crystals to significantly improve the efficiency, but to to overcome the decoherence part, it can be its biggest hurdle in making the quantum batteries practical. So, what are the potential game-changing applications? So, if realized, quantum batteries could transform multiple industries. Electric vehicles could be the one of the best industries that could be benefited by this. It could We could charge the vehicles very fast, and since it has a super absorption property, it can hold the charger for a longer time, and it could increase the range. So another application can be renewable energy. It could be stored efficiently, making 24/7 clean energy possible. Consumer electronics like phones could charge in seconds and last weeks. And medical devices and nanotechnology could gain the reliability and long-lasting power sources. The applications are vast and transformative. The quantum battery market is projected to grow at 24.5% annually, around $18.5 million in 2024 and $65.4 million in 2030. The Pacific region leads innovation with investments from universities and startups and industries. As quantum computing and solid state batteries progress, integrating with quantum batteries will accelerate the commercialization. And to overcome these challenges to overcome these challenges, we can use quantum coherence challenge, one of those challenges that I have mentioned before also, keeping entanglement stable at this scale, and scalable engineering, developing practical designs like atom cavity systems and hybrid approaches combining classical and quantum storage in the short term. Interdisciplinary collaboration between physicists, engineers and industry to move from theory to real world adoption. So these are the challenges we can face. To conclude, quantum batteries promise revolutionary performance, instant charging, higher capacity, and long durability. They could unleash the renewable energy's full potential and reshape how we power our world. While challenges remain, ongoing research and investment are steadily moving us from theory to reality. The physics of the future is here, and it could redefine the energy forever. So that was my take on quantum batteries. Thank you for listening.